Hello, my name is Jordan McCaskill, and today we will be talking about climate change and the physics behind it. We will be looking at the importance of studying and researching it, and we will be looking at the different factors that play a part in it. What is climate change? Climate change can be described as the progressively increase in the Earth's temperature and is also known as global warming. Climate change and global warming is one of the most talked about topics in the world and one of the most controversial topics. Whether you believe in it or not, there is evidence that can back it up. According to the American Physical Society, the global average temperature has increased by approximately 1 degree Celsius in the last century. There are many different reasons or factors that play a part in this global warming idea. One being the result in the emissions of greenhouse gases from human activities are changing the atmosphere in ways that affect the Earth's climate. Pollution, overpopulation, or maybe even the Earth tilting are all ideas behind climate change.
Weather and climate are driven by the absorption of solar radiation and the subsequent redistribution of that energy through radiative, advective, and hydrological processes. The Earth's surface temperature is primarily determined by the balance between the absorption and emission of radiation. A change in this radiative balance is termed a radiative forcing, which is measured in watts per square meter according to the American Physical Society. Naturally occurring greenhouse gases, primarily water vapor and carbon dioxide, trap thermal radiation from the Earth's surface, and this effect keeps the surface warmer than it would be otherwise. Human activities are causing an enhancement of the natural greenhouse effect by substantially increasing the atmospheric concentrations of greenhouse gases. For example, the atmospheric concentration of carbon dioxide has already risen by about 30% from its pre-industrial level, and methane concentrations are more than double their pre-industrial value. Further substantial increases in carbon dioxide concentrations are inevitable, at least in the near term, as worldwide use of fossil fuels continues to increase, according to the American Physical Society.
What is the importance of studying and researching climate change? Studying this topic helps make the government make informed decisions on energy use, CO2 reduction mitigation strategies that can be based on sound evidence. It is an extremely important topic to discuss and look at so we can understand why these things, such as global warming, sea level changes, animals dying off, and CO2 increases, have occurred. By studying these topics, we might be able to recognize what we as humans can do in order to prevent further harm to the environment. The leading cause of global warming is due to humans, and we are the only things that can prevent it from getting worse. The factors of light and heat play a big role in climate change. The light and heat from the sun are emitted on the Earth's surface. Some of this light and heat is absorbed by the Earth's surface and materials, while other light and heat is reflected and sent back into the atmosphere. This fractional reflectance is known as the global mean planetary reflectance, or albedo, which stands for A, which is around 0.3. This slide shows the relation of albedo and blackbody radiation. The equation on the right shows the equation that can be used to show the amount of light and heat absorbed by the sun compared to the light and heat that is reflected back into the atmosphere from the Earth's surface. How much warming does carbon dioxide itself contribute to the current surface temperature of the Earth? We can calculate the CO2 flux density at concentration in the current atmosphere using the fundamental equation F equals 5.35 natural log of concentration. This equation gives the increase in heat flux density, change of F, in watts per meter squared when CO2 concentration increases from CO to CppM. Calculation of CO2 flux density in comparison with the other non-condensing greenhouse gases that maintain a temperature structure for the atmosphere. CO2 is not the only type of gaseous particle that change the atmosphere. The following equation can be used for the derivation of temperature increase in the atmosphere. The assumptions we will make allow us to represent the real atmosphere. This remarkably reasonable representation of the real atmosphere is due in part to the small mean optical thickness of the Earth's atmosphere. Instant doubling means there is no feedback from a change in water vapor opacity due to a change in temperature. Stefan-Boltzmann law is the intensity at the surface of a black body is directly proportional to the fourth power of the temperature and is given by the above formula. For real materials which are not perfect black bodies, the right-hand side is multiplied by the emissive, which is a number between 0 and 1. If E is the radiant heat energy emitted from a unit area in 1 second, and T is the absolute temperature in degrees Kelvin, the Greek letter sigma represents the constant of proportionality called the Stefan-Boltzmann constant. This constant has the value of 5.670367 times 10 to the 8th watt per meter squared per Kelvin to the 4th. The key scientific principles can be seen by considering the energy balance of the Earth. The Earth receives energy from the Sun and it sends energy back to space. Every physical body that is warmer than its surrounding loses energy to its surroundings because of the temperature of the Sun. The form of energy that escapes it is mostly visible light, while the temperature of the Earth causes most of the energy sent away from the Earth to be in the form of infrared wavelengths. The Sun emits an intensity of light that's around 10 million times that of Earth. The Earth being so far away only absorbs a tiny fraction of this light, but the Earth also radiates the energy absorbed during the day back into space at night, but it isn't radiating visible light. The other main difference is the So in conclusion, climate change is happening all around us in many different ways and forms. It happens due to many different causes as well. Human activities has caused a change in climate. The average global temperature has increased from the past years. Sea levels has risen. The amount of Arctic ice has decreased. CO2 levels in the atmosphere has increased. All of these things are areas that need improving, and we as humans can keep researching and studying climate change in order to better our future.
And on this slide is the reference page for the PowerPoint.